Hello everyone, how are you? I hope you all are doing well. In this video, we will try and understand the perceptron neural network, which is the basic unit of artificial neural network. In this video, we will draw graphs, we will write mathematical equations, we will write data set, and we will feed that data set into the neuron which we will create, and we will also learn how the model training is done. All this in this video. So let's start the training. So perceptron is the basic unit of neural network, and more specifically artificial neural network, which we will study in the next upcoming videos. So artificial neural networks consists of multiple perceptrons, and therefore we call perceptron as basic unit of artificial neural network. Now this perceptron is also called a single layer neural network because it is having only one hidden layer in this, and this hidden layer is responsible for all the magic. What is a hidden layer? We will understand in great detail when we go to the perceptron architecture. Now this perceptron model is basically used for binary classification problems or linear separation problems. Okay. Now, the perceptron has input layer, neuron, and output layer. But there are few other things in the perceptron which we will understand in great detail further. So, let me show you the input layer, the hidden layer, and the output layer in the below diagram. So, here we have the input layer. Before going to the input layer, let me also explain you what is binary classification problem. So binary classification problems are the problems where for any number of inputs, the output is of the binary form. So always the output will be of the binary form, that is, the output can be yes, no, the output can be pass or fail, the output can be of the 0 or 1 form. So anywhere when the output is of the binary form, the problem is mostly the binary classification problem, and in this there can be any number of inputs. So let us assume that there are n number of inputs. So x1, x2, x3, xn. I will also give you a simple example to understand this. So suppose there is a scenario where you are having data of students, and this data is basically related to the IQ of the students. So you know the IQ of the students, you know the number of study hours they have studied for, and what was the actual output of their examination, whether they got passed or failed. So you already have this data. Now using the hidden layer, you will find the predicted output. Okay, and this predicted output you will try to match with the actual output and find the error, and on the basis of this error our model training will happen. So you have the IQ of students, you have the number of study hours for which the students studied, and you have the actual output, whether the students got passed or failed. On the basis of this data, we will try to train our model, and we will try to create a model which will further do predictions for us. Okay, so this is what we are trying to solve. So we can have any number of inputs, like in the example which I showed, I have shown you two inputs. So those two inputs are the IQ and the number of study hours. Like that, you can have any number of inputs, for example number of play hours, number of travel hours, so on and so forth, and all these inputs will go into the hidden layer. So this is the hidden layer which we were talking about, where the magic happens. Now this hidden layer is having two partitions in it where two steps are executed. But prior to hidden layer, there are two more things which we need to understand, which we will understand when we study the components of the neural network. And after the hidden layer processing is done, that is the step 1 and step 2 of the hidden layer are completed. Step 1, step 2 of hidden layer is completed, then we will get the output, which is the predicted output, and which will be of the binary form. Cool. So we have these many components. Further, let us go through the other components. Now, as we know, we have input layer in which we have IQ, study hours, and like that it can take many number of inputs. We have marked x1 as IQ, x2 as study hours. We will also have the weights. Now, please pay attention. Weights are the most important component of this. So weights will determine the importance of each input. Okay. So I will give you another example. So as I said that we have IQ of the students and we have the IQ of the students and we have the study hours. Now someone asks me how important the IQ is and how important the study hours are when we are trying to predict whether the student will fail or pass. So I tell them that IQ is as important as the study hours. What does this mean? This means that W1 is equals to W2. So W, that is weight, tells regarding the importance of the input parameter. So how important the parameter is. If the two parameters are equally important, their weights will be equal. So the weights determine the importance of each input. The weights are randomly initialized, and the most important part which we will encounter very often is updating the weights. The weights will be updated during the training, and this is all about the training of the model. So updating weights is the most crucial part of training any natural language programming model or any deep learning model. Okay, so these weights are initially randomly initialized. For example, I can show you here. We have in the first step initialize the weights randomly as 1 and 1, and when we will find the error, then we will try to update the weights on the basis of this error using something called as back propagation. So using something called as back propagation, and this we will learn in the upcoming videos. Cool. So we know what are the weights. Now we will go to the next component, which is called as bias. Now why for do we have bias? So bias is required because we will be passing the weights and the input parameters to this linear combination function, and if the weights and input parameters are all zeros, then our linear combination function will also become zero. So to prevent all the outputs from being zero, we require the bias, which is again some value. Let us say 1. In our example, we have assumed the bias to be 1 for ease of calculations, but bias can be like 0.1, 0.2. Okay. Flexibility like intercept in regression. This point we will understand when we will try to learn what is regression. Now let us come back to our hidden layer, which will do the magic. So this hidden layer will execute 2 steps. Okay. The first step is called as linear combination. So the first step is called as linear combination, and the second step is called as applying activation function. Now we will go through these steps. So first is linear combination. In the linear combination, what we will do is we will add the products of weights with their inputs along with the bias. So for example, in our IQ and study hours example, for that what we will do is we will do W1 x1 plus W2 x2 plus bias. Okay, because we have only 2 input parameters and these can be in any number. So if I generalize this equation by removing the summation part, if I generalize this equation for ease of reading, let me generalize this. So generalizing this, W1 x1 plus W2 x2 plus dot 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 plus Wn xn plus bias. So we will do the sum of product of all the input parameters with their weights. Okay. Now this way we will get a value for the linear combination. Okay. So this value can be anything, right? But as we know that we want the output only in the binary form. The perceptron is meant to give the output in the binary form. To convert this activation function, linear combination value into binary form, to convert the linear combination value. So basically this linear combination value I have to convert to the binary form. And to do this, to do this, we have got activation functions. So this is what the activation function will do. It will convert the linear combination function value into binary form. Okay. So there are multiple types of activation functions. For example, we have step function, we have sigmoid function. For our example, we will consider sigmoid as the activation function. Okay. And we will study each and every activation function in great detail in the upcoming videos. So you need not worry like what exactly is activation function. I will explain you each and every activation function by drawing its graph. We will also do multiple mathematical things with these activation functions and to understand like which activation function is more efficient as per the model training is concerned. So activation function plays a major role in the model training and it helps us to update the weight. Now, we will take this example. So this is a sample data set where we have the IQ of the students, we have the IQ of the students, we have the number of study hours of the students, we have the actual output whether the student got passed or failed, and on the basis of this data we will try to train our model. Okay, so we will, in this example, we will do the first step of our model training. The subsequent steps we will take up in the next videos where we will update the weights and we will repeat all the steps which we are doing in the first step. Okay, so in the first step, as I told you, we have to find the linear combination. Okay, so let us find the linear combination. Now, what was the linear combination? Linear combination was x1 w1. Now, for this we require the w1 value. So let us assume that our w1 value for this step is 1 and our w2 value also for this step is 1. Let us assume that. Okay, so both IQ and study hours are equally important. That is what we are trying to say. On the basis of this, what we are trying to calculate is x1 w1 plus x2 w2 plus b. So we want x1 w1 plus x2 w2 plus b for all this data. Now we know that w1 and w2 are 1. Therefore, we will get 100 into 1 plus 8 into 1 plus 1, because bias also we have assumed as 1. Let me highlight the bias. This is the bias we have assumed here as 1 for ease of calculation. So this value will come out to be 109. Similarly, for other data, we will have the values as 88, we will have the value as 67, we will have value as 50, we will have value as 31. So this is our linear combination value. And now we will find the predicted output by applying the sigmoid function. Now what we will do is we will apply to all these values, we will pass all these values into this formula. Okay, into this formula which is the sigmoid formula. So in this sigmoid formula we will pass all these value 1 plus e to the power 1 upon 1 plus e to the power minus z, and we will get a value which will be in between 0 and 1, and we will approximate it to either 0 or 1, and therefore we will get the predicted output. So let us assume I passed 109 to this equation and I got a value which is 1. I passed 88 to this equation, I got a value which is 1. I passed 67 to this equation, I got a value which is 0. Similarly, I passed 50, I passed 31, I got value 0. And therefore, the error for this is, now, how to calculate the error? So we will assume that pass is 1. We should have already assumed it before only. And therefore, error for first is 0, second is 0. For third, by mistake, I think I wrote 0 instead of 1 here. So let me rub it. Okay. Yeah. So error is 1 here, error is 0 here, it is 0 here. So now, in order to eradicate this error, we will update the weights. Okay. And to find out what are the updated weights, we will do the back propagation. Okay. And this, using this back propagation, using gradient descent and all these techniques, what we will do is we will find out the new updated weight, which could be say 0.9, 1 and 1.1. And then we will repeat this step to reduce the error to minimum, that is almost 0. Okay, so after getting these weights values, our model will be ready for other inputs to predict the output. Okay, I hope this was clear. Now, as we get the weight values, finalized weight value, making the error approximately 0, we will get the weight values. Say the weight values are 0.8 and 1.2 final weight values. Then our hidden layer will look like this. Our hidden layer will have the activation function. Sorry, our hidden layer will have the linear combination function, which will look like this. That is 0.8 of x1 plus 1.2 of x2 plus bias, which is 1. And using this, we will make the next outputs. So this looks like a linear equation. Let me remind you what is the generic linear equation formula. So generic linear equation formula is y equals to mx plus c. So this is kind of y equals to mx plus c. So now we should be able to plot it on the graph also, since it is of the linear form. So we will try to plot this data set on the graph and understand like what exactly we are trying to do. So let me quickly write all the data sets here. So all values are plotted on the graph. Now let us plot the points on the graph. So we will consider the actual output, and for pass we will mark the actual output as green. So for pass I will mark the output as green, the point as green, and for fail I will mark the point as red. Cool. So we have 100,8 and 80,7 as green. So 100,8, this is 100,8 and 80,7. So this is 80,7 as green. 6,60 and 9,40. So 6,60 is here, 9,40 is here, and we also have 10,20. So 10,20 is here. So these are the points. So the green dots tell that the student, so this particular student got passed, this particular student got passed, this particular student got failed, this particular student got failed, this particular student got failed. Now what exactly we are trying to do here? Let me write it again for better view. So we want y equals to mx plus c. Okay, so what we are trying to do here is we are trying to draw a line. So we are basically trying to draw a line, and this line will separate the green dots from the red dots. Cool. So this line will separate the green dots from the red dots, and for any other further data, suppose someone tells to predict the output, someone tells our model to predict output for a student having 100 IQ and studying for 10 hours, it will come somewhere here, and we can easily say that this student will get passed. Correct? So this is for a simple 2D model, that is the 2-dimension model where we are having 2 inputs. So we had IQ, we had study hours, and the output was pass or fail. So first of all, we multiplied the inputs with weights and added the bias. We also applied the activation function to get the output as 0 or 1, and we compared the predicted output with the real output to get the error. And if the error was there, then we updated the weights, and then we repeated these steps until the error is minimized. Now, updating the weights and repeating this process we will go through in next videos when we will understand the back propagation. Okay. So now, what are the advantages? It is simple and easy to implement because the number of equations are less. It works good with linearly separable problems or binary classification problems, and it acts as a binary classifier. Next, what are the limitations? The limitations are it cannot solve the non-linearly separable problems. The second is that weight update is inefficient, only feed forward, no structured back propagation. So what is feed forward? So feed forward means we are moving in the forward direction. That is, our inputs we are feeding to the linear combination and then applying the activation function. So this direction or this sequence is called as feed forward. So limitation is that here we are only using feed forward, and the back propagation is difficult. Non-linearly separable problems. One good example of non-linearly separable problem is XOR problem. So we will try to understand this by the XOR problem, but by definition these if we are unable to draw any straight line to separate the classes, then it is a non-linearly separable problem. So as we seen in the previous example, we draw a yellow line to separate the red dots from green dots. If no such yellow line is possible to draw, then it is a non-linearly separable problems. And for such problems, we may require to draw curves, circle, multiple layers of decision boundaries, etc. Now XOR problem we will go through, and how to solve the XOR problem, that we will understand in the upcoming videos. But what is XOR problem, we will try to understand. So we know the XOR function, right? So XOR function, if we pass 0 0, it will give 0. If we pass 0 1, it will give 1. If we pass 1 0, it will give 1. If we pass 1 1, it will give 0. So let us plot this on the graph. Let us assume that ones are green and red, and zeros are reds. So we have 0 0 as 0 and 1 1 as 0, and we have 0 1 as 1 and 1 0 as 1. Okay, so let me quickly plot it for you. So this is the graph. This is how the graph will look like. Okay, so we have these points. Now, is there any line which can separate the green points from the red points? Can you imagine any line which can separate the green points and the red points? No, right? You can try. Okay, let us try. Let us try drawing a few lines. So this line is also having red on both sides of it. Okay, let me draw this line. This is having green on both sides of it. Let me draw this line. This is having both red and green on both sides of it. Let me draw this line. Again, we are having both red and green on both sides of it. So there is no single line which can divide all these points into two parts. So since the ones are on the opposite corners of the square and zeros are on the other two corners, there is no straight line that can separate the ones from the zeros. And that's why a single layer perception fails on the XOR problem. So we need the multi-layer perceptron, that is the artificial neural network with non-linear activation functions to solve it. So artificial neural network, that is multi-layer perceptron with non-linear activation function, we will study in the upcoming videos. But this was for you to understand like what is XOR problem and why we cannot solve it by drawing a straight line. And since we are unable to draw a straight line for the XOR problem, we are not going to solve it with the single layer perceptron model. Okay, so single layer perceptron model works with AND OR kind of problems, and the multi-layer perceptron is required for solving the XOR problem. Okay, now therefore we move to the multi-layer perceptron to solve the non-linear problems. And in this we will do forward propagation. We will learn the forward propagation. We will learn the backward propagation also. We will learn what are loss functions. We will learn what are optimizers, what is gradient descent, and we will also understand which are the different activation functions and what is the impact of using which activation function. All these things we will cover in the upcoming videos. Cool. So now let us conclude this video. So what all things did we learn in this video? The first thing is that we found that perceptron model is the simplest form of a neural network, and more specifically artificial neural network, and this is great for binary and linearly separable problems, correct? And for complex or non-linear problems we require the multi-layered neural networks, or ANN, which we will study in the next video. So thanks for watching this video. If you like this video, do subscribe my channel, do share this video with your peers, and if you have any inputs, do share in the comments. If you have any doubts, please feel free to share in the comments. I hope you like the way of sharing the knowledge, and thanks for watching this video. Thanks for your time. Take care. Bye.